properties of addition and subtraction of integers. Closure property. As we know that 12 plus minus 15 is equal to minus 3, and minus 3 is an integer. Thus, the sum of any two integers is an integer. We can say that integers are closed under addition. Hence, if a and b are any two integers, then a plus b is also an integer. Also, 17 minus 19 is equal to minus 2, and minus 2 is an integer. Thus, difference of two integers is an integer. We say that integers are closed under subtraction. Thus, if a and b are any two integers, then a minus b is also an integer. Next property is commutative property. As we know that minus 7 plus minus 12 is equal to minus 19, and minus 12 plus minus 7 is equal to minus 19. Therefore, minus 7 plus minus 12 is equal to minus 12 plus minus 7. Thus, addition is commutative for integers. Hence, if a and b are any two integers, then a plus b is equal to b plus a. Again, minus 5 minus minus 19 is equal to minus 5 plus 19 is equal to 14, and minus 19 minus minus 5 is equal to minus 19 plus 5 is equal to minus 14. Therefore, minus 5 minus minus 19 is not equal to minus 19 minus minus 5. Thus, subtraction is not commutative for integers. Hence, if a and b are any two integers, then a minus b is not equal to b minus a. Next property is associative property. We know that minus 3 plus minus 9 plus 17 is equal to minus 12 plus 17 is equal to 5. Also, minus 3 plus minus 9 plus 17 is equal to minus 3 plus 8 is equal to 5. Therefore, minus 3 plus minus 9 plus 17 is equal to minus 3 plus minus 9 plus 17. Thus, addition is associative for integers. Hence, if a, b and c are any three integers, then a plus b plus c is equal to a plus b plus c. Again, minus 3 minus minus 9 minus 17 is equal to minus 3 plus 9 minus 17 is equal to 6 minus 17 is equal to minus 11. And minus 3 minus minus 9 minus 17 is equal to minus 3 minus minus 9 minus 17 is equal to minus 3 plus 26 is equal to 23. Therefore, minus 3 minus minus 9 minus 17 is not equal to minus 3 minus minus 9 minus 17. Thus, subtraction is not associative for integers. Hence, if a, b and c are any three integers, then a minus b minus c is not equal to a minus b minus c. Let us now talk about an identity called additive identity. As we know that 5 plus 0 is equal to 0 plus 5 is equal to 5. Similarly, minus 8 plus 0 is equal to 0 plus minus 8 is equal to minus 8. From the above we observe, when 0 is added to an integer or an integer is added to 0, the sum is the integer itself. Thus, 0 is the additive identity. Hence, if a is any integer, then a plus 0 is equal to 0 plus a is equal to a. Next is additive inverse. As we already know that 5 plus minus 5 is equal to 0 and minus 5 plus 5 is equal to 0. Similarly, minus 12 plus 12 is equal to 12 plus minus 12 is equal to 0. From this we observe, for every integer, there exists its additive inverse or negative such that their sum is 0. Hence, if a is any integer, then a plus minus a is equal to minus a plus a is equal to 0. Let us now learn simplification by means of an example. Let us simplify 146 minus 200 minus 90. So 146 minus 200 minus 90 is equal to 146 plus 200 plus 90. This gives us 346 plus 90 is equal to 436. About properties of multiplication for integers. Property 1. Let us multiply any two integers and see whether their product is an integer. For example, minus 3 into minus 2 is equal to 6, which is an integer. Thus we see that the product of any two integers is an integer. Hence, if a and b are any two integers, then a into b is also an integer. This is called closure property of multiplication of integers. Property 2. Let us multiply any two integers in different orders and see whether their products are same. For example, 8 into minus 4 is equal to minus 32 and minus 4 into 8 is equal to minus 32. Thus we see that the product of any two integers remains same, whatever be the order of multiplication. Hence, if a and b are any two integers, then a into b is equal to b into a. This is called commutative property of multiplication of integers. Property 3. Let us multiply any three integers by taking them in different groups and see whether the product in each case is the same. For example, minus 8 into minus 10 into 9 is equal to minus 8 into minus 90 is equal to 720 and minus 8 into minus 10 into 9 is equal to 80 into 9 is equal to 720. Therefore, minus 8 into minus 10 into 9 is equal to minus 8 into minus 10 into 9. Thus, given three integers, they need not be multiplied in the order in which they are given. We can group them in easy combinations and find their product. Hence, if a, b and c are any three integers, then a into b into c is equal to a into b into c. This is called associative property of multiplication of integers. Property 4. Let us examine the product of two integers, one of which is 1. For example, minus 5 into 1 is equal to minus 5. Thus we find that the product of any integer and 1 is always that integer. Hence, if a is any integer, then a into 1 is equal to 1 into a is equal to A. 1 is the identity element of multiplication for integers. Property 5. Let us multiply an integer by 0. For example, minus 4 into 0 is equal to 0. Thus, the product of any integer by 0 is 0. Hence, if a is any integer, then a into 0 is equal to 0 into a is equal to 0. Property 6. Let us multiply an integer by minus 1. For example, 5 into minus 1 is equal to minus 5. Hence, if a is any integer, then a into minus 1 is equal to minus 1 into a is equal to minus a. Property 7. Distributive property over addition. We can compute minus 5 into 6 plus minus 3 in two different ways. First, minus 5 into 6 plus minus 3 is equal to minus 5 into plus 3 is equal to minus 15. Second, minus 5 into 6 plus minus 5 into minus 3 is equal to minus 30 plus 15 is equal to minus 15. Thus we see that minus 5 into 6 plus minus 3 is equal to minus 5 into 6 plus minus 5 into minus 3. Hence, if a, b and c are any three integers, then a into b plus c is equal to a into b plus a into c. This is called distributive property of multiplication of integers over addition. Let us solve an example. In 8 into minus 5 plus x is equal to 8 into minus 5 plus 8 into 10, find x. This gives us minus 40 plus 8x is equal to minus 40 plus 80. This implies to 8x is equal to minus 40 plus 80 plus 40. This gives us 8x is equal to 80. Hence, x is equal to 10. Let us now learn about some of the properties of division for integers. We have seen earlier that if any two integers are added, the result is an integer. If one integer is subtracted from any other integer, the result is again an integer. Similarly, if any two integers are multiplied, the result is an integer. Now let us see, if an integer is divided by a non-zero integer, will the quotient be always an integer? We know that minus 8 divided by 4 is equal to minus 2 and minus 16 divided by minus 4 is equal to 4. Here, the quotients minus 2 and 4 in both the cases are integers. But when an integer is divided by another non-zero integer, it is not always possible that the quotient is an integer. For example, minus 5 divided by 3 is not an integer. Hence, we draw property 1, which states that the collection of integers is not closed under division. Property 2. If a is not equal to 0 is any integer, then a divided by a is equal to 1, a divided by 1 is equal to a. For example, 5 divided by 5 is equal to 1 and minus 7 divided by 1 is equal to minus 7. Property 3. If a not equal to 0 is any integer, then a divided by minus a is equal to minus 1, minus a divided by a is equal to minus 1, a divided by minus 1 is equal to minus a. For example, 5 divided by minus 5 is equal to minus 1 and minus 8 divided by minus 1 is equal to 8. Property 4. If 0 is divided by any non-zero integer, the result is always 0. For example, 0 divided by minus 9 is equal to 0. Hence, if a not equal to 0 is any integer, then 0 divided by a always gives the result as 0.